Hi everyone, my name is Thomas Kim. Today is August 23rd, 2020. This is my 28th episode about vector calculus and classical electromagnetism. In this episode, we will learn how to extend C++ container classes. More specifically, we will learn how to extend std vector and QVector in Qt Toolkit. We will also learn how to use initializer list and Java style iterator in Qt Toolkit. Qt Toolkit was created before C++ 17 standard, and QVector, a container class in Qt Toolkit, is not updated or upgraded to C++ 17. So we will learn how to extend QVector to take advantage of C++ 17 standard. Without further ado, let's get started. Start Visual Studio. Please note that I'm using Visual Studio 2019. Go to File, New, Project. In the search box, type Qt, select Qt Console Application. Click Next. Click this button, New Folder, 028, Extend QVector. Hit Enter, select Folder, ext QVector. Click Create. Click Next. Click Finish. If you haven't installed Qt Toolkit and Android Studio on your machine, please double-click this link and watch this video and install Qt Toolkit on your machine. I installed latest version of Qt Toolkit. Click Solution Explorer, right-click, Properties, General. We will be using latest C++. Select Preview Feature from the latest C++ working draft. Click Apply, CPP, General, All Configuration, All Platform, Edit. Click this button, Include. Then your path will be resolved like this. Click OK. Click OK. Now include talk play fun, output HPP, talk play fun, S stream, auto NL, talk play fun, NL. Now void test QVector, int q 0, 1, 2, 3, 4, 5, 6, 7, 9. I will include QVector here. Include QVector. And I will arrange a little bit. I fixed our code like this. Now stream q equals q and there. We call this function copy, paste, Ctrl F5. So QVector Q is displayed like this. QVector has very interesting things. Q, 10, 11. Now we display QVector again. Ctrl F5. So using output operator, we inserted two elements, 10 and 11. 10 and 11. We want to extend std vector to support this operator. Namespace, ext, template, type name, container, type, class, support, output, public, container type. Container type is template parameter. Template parameter is used as base class. This way of programming is called curiously recursive template. I forgot the name. here public template type name T friend support output. This is L value reference operator support output L value reference SO T forwarding reference ARG. Now here SO in place back STD forward T ARG. We have to return SO. Now we test this class. This class defines output operator as friend function. Now here void test support output. This namespace ext support output std vector int. I will put a blank space here for easier read. V 0 1 2 3 4 5 6 7 8 9. Now string v equals v and there. Now we call this function copy paste it here. I will disable it. Ctrl F5. It failed. No. If we scroll up, initialize cannot convert int to vector. So we need using container type. We have to declare base classes constructors. This is base class. This is constructor. Now Ctrl F5. So our V works correctly. Now here V 10 11. I copy once again, paste. We build again, Ctrl F5. So this is a vector. We defined output operator like this, then it works perfectly. But there is a problem. Now I will close it. I will show you what's the problem. I will copy, paste. I will disable it. Now this is set. Okay? If we press Ctrl F5, it does not work. The error message says in place back is not supported because set does not support in place back. How can we solve this problem? How? To solve this problem, we need concept. Concepts are introduced in C++20. If you want to know what is concepts in C++, please refer to this video. I created concept, 6 tutorials about C++20 concept. Now we can use concept like this. I scroll up here. I will try to explain every minute details. Template, type name, container type, concept, in place back, T requires. We can create container type, container, don't forget semicolon. Requires can create or take argument. Container type comes from template parameter. Now here container dot in place back, we are calling containers member in place back. Here we have to provide an argument. Container type should have value type member. For simple application, this is good enough, but this is not perfect. This is called simple requirement. Now here I will create another one. Template, type name, container type, concept, implies T, requires, container type, container, don't forget semicolon here, container, implies, container type, value type. For simple application, this is good enough. But what if value type does not support default constructor? For such case, we use std 댓글 var. It requires a type. Then create a dummy instance. Here we need type name. Now I will copy this, copy, and paste it here. Okay. Now here, template, type name, container type, concept, in place server T, in place server T, in place back T, container type, or in place T, container type. This operator is called disjunction. Now scroll down. Here we can use our concept like this. If context pair in place back T, we test if this container type supports in place back. Else if context pair in place T container type, then we can say in place. So using concept in place back and in place T, we used if context pair. If context pair was introduced to C++17. Now scroll down. This support output passing std set. Now this output operator is supported. Ctrl F5. So this is a set initialized with 10 elements. Then using output operator, we successfully inserted 10 and 11 new elements. Now I will change it to V1. This is S1, V1, 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 V1. I copy, paste. This is S1, 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 S1. Now press Ctrl F5. Now everything works correctly. Now scroll up. This support output class should support either in place back or in place T. For such use, we created in place server. Copy, paste. So the container type for support output should support either in place back or in place T. Finally, Ctrl F5. It works perfectly. For more information about concept tutorial, please double-click this link. From episode 18 up to episode 25, I filmed 6 videos about C++ 20 standard concept.